We will go ahead and we will talk about a new model, and this model will be called the car model. Ideally, this is just one model that I'm doing with you, and this has got nothing to do with a specified case. I mean, you can get any of the models in exam. What you have to take away from this model is basically how you solve implicit functions. The question is not whether it's a car model, it's a pollution model, it is a smoke model. No. The question is, if you get utility functions which are in implicit function format, how do you go about solving those utility functions, and how do you go about finding the equilibrium in those utility functions? That is what we are going to do today. So you can name this model as the car model. And let's see what this model is saying. So let's say that there are two agents. And the aim of these agents is to decide how fast they should drive the car. So the the decision making is, so the decision is how fast to drive car. Okay. And we're given the utility function. So let's say that this is the utility function of agents. So I represent it like xi, yi, and I write it as u of xi plus yi for every agent I. For me, I'm just taking two agents, so I can take value 1 or 2. So if it is agent 1, it will be ux1 plus y1. If it is agent 2, it will be ux2, y2. And let's say that we also assume two additional things. So we are assuming that u dash is greater than 0, but u double dash is less than 0. By now, you should be able to interpret what this means and what this means. So when I say u dash is greater than 0, I am saying how my utility changes. As x changes, this is greater than 0, which means my marginal utility from x is greater than 0, which means for every unit of speed that you increase, x in this case represents the speed. Please write down. So x represents the speed of the agent I, and yi is all other goods. One more thing here we have, okay. So, usually whenever you will have utility models given to you with a special focus on one good, for example, xi could have been rice, xi could have been smoke, usually they will give a cigarette model or they will give a pollution model. Yi will always represent all other goods, right? Because there is a special focus on one of the goods which I want to go ahead and analyze. So my all other goods are represented by yi. That's the first thing. And whenever that will happen, this particular yi, its price will always be given as 1. And if price is not given, you can take it as 1. And we know that when we take price as 1, that is called the numerator price. Why do I do that? I do that to dampen the effect of Y. I want to reduce the effect of Y. I don't want to overemphasize on Y on all other goods. So usually I will say, okay, if I have to write the budget line, and suppose Xi would have been any commodity that I would have focused on, then I would have said that, so how do I write my budget line? Price of X into units of X plus price of Y into units of Y is equal to income of the consumer. When I put PY as 1, I am saying price of X into X plus 1 into Y is equal to M. So I'm saying M is equal to, Y is equal to M minus PX into X. It's also called composite good. You're correct. Yes, it's called composite good. And what does it mean here? So I am saying that this is my expenditure on good X. This is the income of the consumer. The difference between income and what I spend on good X, that is the remaining money with me. And this remaining money is exactly what Y represents. I can spend on all other goods except X. So I don't have to put price of Y as something, because Y is not one commodity here. Y represents all other commodities. So we will, normalize or dampen the effect of Y, and we will say that, okay, my PY is simply 1. This is what I will just put. This you will see in a lot of questions. Mostly ISI questions will have this, one of the goods as all other goods. So coming back to this. So I am saying that U dash is greater than 0, which means that marginal utility from X is greater than 0. So every increase in speed gives me additional utility, which is positive. But this says that U double dash is less than 0. So d square U by dx square, this is less than 0. So del of del x, del U by del x, this is less than 0. Del U by del x is just marginal utility. So I'm saying del of marginal utility with respect to del x, this is less than 0. Which means although every additional unit increase in speed gives me positive utility, but that utility, additional utility, that is declining. So this is just the law of diminishing marginal utility. That's it, right? So this is the basic assumption that marginal utility is positive, but it is diminishing. Now, let's say that we want to go